Hey guys, today we're going to be doing a totally inelastic coalition with a wall. So let's pretend that we have a wall on this side and that we have a blob. A blob. Let's say we threw a blob in that direction at some velocity v. Now let's say that the blob weighs 200 grams. The initial velocity, let's say that is 15 meters per second. The change in time, so the time it took us to throw that onto the wall, let's say it's 25 milliseconds. And of course we know that once our blob here hits the wall, we know that our velocity, so we can say velocity final, will be 0 meters per second. Now we're interested in finding the force, so I'm going to write the question here. We're interested in find the force of wall on the blob, So we're interested in knowing how much force this wall is applying onto the blob once it hits it. But we know that forces are equal and opposite. So if we have, and this is just for scratch work, you have a object A and object B. We know that their force, let's say force A on B is equal and opposite to the force of B on A. So we know that by finding the force that the blob has on the wall will be equivalent and negative to the force of the wall acting on the blob once it hits this wall. So we can get right into our work, and this is how we're going to proceed. First, we know that we know the formula of impulse, which is the average force equals to the change in momentum over the change of time. So we can rewrite this whole thing as force, I'm just going to write it as force now. Force equals momentum 2 minus momentum 1. That's the same thing as a change in momentum. And on the denominator we have the change in time, so time 2 minus t1. So we know that our momentum 2 here, our momentum 2 there, is going to be, once this blob, this right here, hits this wall. So what is our momentum once this blob hits this wall? Of course there's going to be no momentum, and if there's no momentum, then it's going to be 0. But just for simplicity purposes, I'm going to write the equation of momentum here on this side is going to be, before the coalition, is the mass of this blob times its velocity. Alright, so that's before the coalition. Now after the coalition, and I'm going to put here an A for, well, I'm going to put here a B for before and an A for after. So after, this is before. After the coalition is also going to be m times v. But we know that after the coalition, this blob here is going to have no movement, so no velocity. So the mass of the blob after the coalition is 200 grams, or 0.200 kilograms, times 0 velocity, which is 0. So we don't have a momentum at P2. So this is the same thing as P2. P2 here is equal to 0. Now, P before the coalition, we have also, so here I'm going to put an arrow. we have 0.200 kilograms, and notice that I'm converting my grams into kilograms. Now my initial velocity is 15 meters per second. So now we multiply those two numbers to get 3, and that will be kilograms meters per second momentum, and this is equal to P1 because it's before the coalition. So here P before the coalition is equal to P1. So now we can plug in those values into our formula. So these are wanted items here. Let me change pens. So this is what we wanted. So now we know that we can plug these two onto our equation here. So I'm going to rewrite my equation now down here, and I have my force, or my, give me 1 second. We have my force is equal to my P2, which was 0, minus my P1, my momentum 1, which was 3, over the change in time at T2. We're going to have my milliseconds here, 25 milliseconds. So we can write that in terms of seconds. We can write it as 0.025 seconds minus 0, because at T1 we have 0. So that's going to give us a minus 3 divided by 0.025. And remember, the 3 is kilograms per meters per second. And this is seconds here. So my units should cancel, and I'm going to have my answer in newtons. So here my answer, once I divide that, I should get minus 120 newtons. So now I know that the wall here, once this blob hits this wall, the wall will be providing 120 newtons that way. And we also know that the blob is going to be hitting the wall with 120 newtons as it approaches this wall. And that is the end of the problem. I'll see you next time.